Okay, this is Dr. Williamson. I'm going to do some Lewis structures for you. This is from a Lewis structures handout that I give some of my students. So here, let's take a look at this one. We've got HCCH. Each hydrogen gives us one valence electron. Carbons give us four each. You're writing it kind of crooked and sideways, but writing on my mouse. That's eight. That gives us a total of 10 valence electrons. Now, we're supposed to put the least electronegative atom in the center. The least electronegative atom is the one that is furthest away from fluorine, and hydrogen is way over here. And there's hydrogen. But hydrogen is always a terminal atom. Hydrogen only makes one bond because its electron configuration looks like this. It can only put another electron in here, right? So hydrogen doesn't do the octet rule. It does a duet rule and can only make one bond. So it is always a terminal atom. So hydrogen won't be the central atom. Carbon will be. But I have two carbons. But when you have a situation like that, you put them both in the center. And then you use a pair of electrons to bond them. And then you use a pair of electrons to attach the hydrogens here and here. It's 2, 4, 6. So 10 minus 6. We kind of erase this and make some room. Okay. Now I've got 10 minus 6 leaves 4. I'm going to put 4. 1, 2, 3, 4. No matter where I put those, I'm not going to satisfy the octet rule for carbon unless each one shares them between them. When I do that, I will get this. Excuse me, I did that too soon. I get this. Now, each hydrogen thinks it has a duet of electrons. Each carbon thinks it has 2, 4, 6, 8. Now, obviously, carbons are atoms. They don't think. That is just a manner of speaking. Okay. So when I'm done here, this is going to be and this carbon has 1, 2, 3, 4 shared pairs of electrons, no lone pairs of electrons. Okay. And that is Lewis structure for that. ClCN. Chlorine has 7 valence electrons. Carbon has 4. Nitrogen has 5, right? And that's going to be 16 valence electrons. The one that is furthest away from fluorine will be the central atom. So I'm going to make that carbon. And I'm going to put chlorine as a terminal atom. I'm going to try putting it here. And then I'm going to try putting nitrogen over here. I'm not going to put it on the chlorine because chlorine's a terminal atom. Okay. Oh, excuse me. Let's see here. Chlorine is 7, 8, 9, 10, 11. Yeah, 16. 2, 4. Subtract off 4. That leaves me 12 valence electrons. Try and satisfy the octet rule. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've satisfied the octet rule for everybody except for carbon. Okay. So the way this is going to have its octet rule satisfied is the nitrogen is going to share 2 pairs of electrons. And when I'm done, I'm going to have this 1, 2, 3, nitrogen, lone pair of electrons. 2, 2, 2, 2, 2, 2. And that is the valence structure for that molecule. Okay. I'm going to clean this up a little bit. It's a little bit messy. Just to get rid of some of the clutter. Okay. Now let's see here. Pen. I'm going to change colors because I feel like it. Phosphorus has 5 valence electrons. Oxygen has 6, but I have 4 oxygens. So 4 times 6 is going to be 24. The 3 negative means I have an excess of 3 electrons. So I'm going to have 3 here. So 24 plus 5 is 29, plus 3 more is 32. Phosphorus will be the central atom. Pair of electrons to connect each oxygen. I'm going to need to move that. this. Okay. So put that 4 back. All right, go back to my dark green and my thickness. Pair of electrons to connect this. Pair of electrons to connect this. Okay. And 32 minus 8 leaves me 24. Each oxygen needs 6 more. 6 times 4 is 24. So if I do that, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And then to finish things up, here, here, here. Put a line here, line here, line here, line here. Then I need to put brackets to tell everybody that it is an ion and it is 3 negative. And if you go on the internet, let me go look this up real quick. Go on the internet, let's see here. You'll end up with a Lewis structure sometimes that has a double bond in here somewhere. And if you're in my intro chem class and you put a double bond in here, I'm going to be highly suspicious that you went and looked up the answers on the internet, because I haven't taught you about formal charge to get these answers and to get the double bond stuff for these answers. And so that'll make me very suspicious of what's going on, and please don't do that. Okay. Now I'm going to do this last one, CH4O. And to do that, I need to clear up a lot of space. Boom, cleared up a lot of space. And I'm going to clear up this stuff too. Boom. Get the eraser, clear up that. And pen here. I'm going to do dark blue. CH4O. Right, CH4O. Carbon has four hydrogens, gives me 4 valence electrons. Oxygen gives me 6. That's a total of 14. Carbon is about here. Oxygen's about here. The one that's furthest away from fluorine will be the central atom, so I'm going to go carbon. Hydrogen's always a terminal atom, so I need to connect oxygen to this. So I connect oxygen. Now I'm going to connect the hydrogens. 1, 2, 3. I got one more hydrogen to connect. Where am I? I'm going to have to connect it here. 4. So now I got to go 2, 4, 6, 8, 10. Subtract off 10.
Yeah, they were.
means I've got 4 valence electrons left. I'm going to put those on here and here. I've satisfied the octet rule for everybody. And so now the structure for this, Lewis structure for this, will be here, here, here. There. That is the Lewis structure for CH4O. Okay, guys. I hope that helps. I'll always be posting new stuff as time goes on. And leave comments or suggestions. Okay, I'd be happy to help if you have specific questions. Okay, bye.